Here we are in the summertime, and as the song says, the living is easy. Because everything you need is there if you do your job. But in the wintertime, ain't no living at all. And so we've got to have some strategies to get through the winter. So here we are in the same meadow I just showed you. Okay, overwinter strategy number 1, used by all native bees, slide. Take only enough from the meadow for each egg to develop into an adult, slide. At the summer's end, all adults die, slide. Next generation develops an underground cell, slide. So this is what's going on under the ground. All the adults die. There's no more bees left. In the wintertime, overwintering strategy number 2, used by bumblebees, take only what's necessary to support the colony. Have we heard this before? Yeah, take only what's necessary. Except for new queens, everyone dies when the bloom period ends. New queens hibernate underground. And here we are. We've been here before. Native bee anatomy. Let's look at the anatomy. On your handout, you'll see that native bees have 4 wings. And 4 wings are hooked together so they fly as one wing on each side with a special apparatus. And you can see here that there's little hooks called hamuli, and that's a hard word to get into an after-dinner conversation, but I'll show you some closer view. You can see the hooks a little better here, and if we look another, you can see them quite well here. These little hooks hook the hind wing and forewing together, and it makes it possible for the bees to carry massive loads because it makes the center of lift and the center of gravity compatible so that they don't crash in the ground or drop out of the sky when they hook their forewings together. Is this a bee or a wasp? It's number 31 on your handout. Looks like a wasp to me. You look at what this bee, what we see is little hairs here. Little tiny hairs, and the rest of it looks like a wasp. Is it a bee or a wasp? Well, you're going to have to look at that spot, and if you're my granddaughter, you'll get out my microscope and you put the bee under the scope, and this is what you want to see in those little hairs. Looks like a bunch of split ends all the way down the hair. It's called a plumose hair. It means feather in French. A plumose hair, and that's what the pollen sticks to. Isn't that cool? So we've got plumose hairs everywhere, and the pollen sticks to it along with electrostatic charges, and it makes it a very efficient pollen gathering device. Now, this is not the way they all get carried home. They get cleaned off, and they do all kinds of running their legs through little notches and various things. Normal human, how many appendages have you got? Most of us here have got 4 appendages. 2 arms and 2 legs, 4 appendages. How many native bee appendages? Take a look at your handout. Let's see, I see 2 antennae. And how many wings? 4 wings. And how many legs? Okay, we got it. So we got 4 wings, 6 legs, 2 antennae, 12 appendages. Can you imagine? You've seen teenagers who are gangly walking down the stairs. Can you imagine being a bee with 12 appendages you're trying to learn to manage? What about eyes? You got 2 of them. How many eyes does a native bee have? Well, let's take a look. We've got 2 big eyes here that we can see. If we take a little closer look, we see something special. What are these little funny... Let's take a closer look. If we take a closer look at that, what we see is there's little hexagonal pieces, and if we took those apart with a microscopic view, we'd find that each one of those little hexagons was a lens with a separate nerve that goes to the optic nerve so that each separate lens sees one thing, and if something moves in the field so that it goes to a different lens, it's a different nerve, and the bee says, whoa, something's moving, and it gets the dickens out of it. They're sensitive to motion at a level that you can't imagine. So we stack those up, and then we stack them up in a bunch, and here we've got the classic compound eye with hexagonal lenses that go out to an optic nerve. Now they also have, all the Hymenoptera bees, ants, and wasps have these 3 ocelli that primarily are registering how light it is. The sun's coming up, better get out there and get your work done because there's going to be competition in an hour. And some bees are only there in the first hour of sunrise and they're gone. And others are only there in the last hour of sunshine before it gets dark. And that's how they tell what the time of day is. So we got 2 compound eyes and 3 ocelli, and so there's really thousands, but we're going to call them 5 eyes. There's 8 species of bees in Washington that have a problem. Anybody ever had an eyelash in your eye? Drive you nuts. But if you were one of those 8 species of bees, you'd have hair growing out of your eyes. Hair growing out of their eyes. There's 8 species in Washington like that. I don't know what that's about. Some people say that it's an airspeed indicator that the bees use. I don't know. All native bees have segmented antennae. And if we look at the antennae, we see that native bees have an antenna. If we count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So what is this, a male or a female? 12 segments is a female, 13 segments is a male. Remember that. I'm going to come back and ask you in a little while. How many for a female? 12 segments. Okay, good. Who's going to tell me what's in this bowl? Spinach. Y'all are parents. You know what that is. And Mom made you eat the spinach because you had to eat the spinach in order to stay healthy. And the reason you had to do that was because you had red blood cells. And what the red blood cells are about is carrying oxygen and the hemoglobin. And you carry the oxygen from your pulmonary alveolus, then carry it around in your red blood cells, and you carry it all the way to the muscle cells, and that's how you can do muscle work, is you got the oxygen in your blood. That's what your lungs are for. Bee blood is clear like water. It's not red, it's clear. Raise any questions? They don't have red blood cells. What they've got is little spiracles on the side. They got a circulation system like your air conditioning that goes to each room. Actually, what it does is if you look at those spiracles on the outside, what you've got, here's the hole, and this is the outside wall of the bee. Then you have like breathing tubes that go down to every muscle cell, every cell in the body. And that's the factor that limits how big a bee can be, is that they don't carry oxygen in their blood. They've got a ventilation system like your air conditioning system in your house that goes to every cell in their body, and it limits how big they can become. Now out in the field, sometimes I find a feather like this. And this is a mystery to a naturalist, because I know that there's some nasty things that sometimes happen to birds. This feather seems to be intact. It isn't broken. Why is a completely good feather on the ground? Well, twice a year birds molt, because feathers wear out. And they molt and they drop all their feathers and grow new feathers. The feathers are made of chitin, and so is our hair and our fingernails and birds' feathers and hooves and claws. They wear out. New hair and feathers replace the old. But with bees, they don't have the same problem or the same situation we have with their fingernails that we grow continuously. Instead, when they emerge, they've got a set of wings, and that's the set. And it's kind of like buying a car with one set of tires and you can't get any more, and when the tires wear out, you're done. So we see a younger bee, and it's got an intact wing, and the older bee is getting ratty, warm, and pretty soon they're flapping like crazy, and they can't go anywhere, and they fall down and die. Now, gender differences are kind of interesting in bees. Guys like this part, because if you're looking at gender in bumblebees, males can't sting, and so if you happen to look at them and notice that it's got a mustache, it's a male, and if it doesn't have a mustache, it's a female. Now, it's pretty hard to do that in the field because not all of them cooperate for facial views like this, but that happens to be a valid tool if you can use it. Bees carry home pollen, and only the females carry home pollen. Honeybees and bumblebees carry the pollen like in a satchel on each side. And now they're going to fly with a satchel carrying all the weight on each side. And their wings and their body are set up so that they'll have a perfect balance between the center of lift on their wings and the center of weight on the satchels. But that's only one way to carry pollen home. Now, honeybees and bumblebees both have this feature on the hind leg is very broad. And it's concave. And it's slick and smooth. And it's surrounded by long eyelashes on either side. And so what the honeybee does, and what the bumblebee does, is it sucks up, it gathers pollen, and then it sucks up nectar out of the plant, and it digests it. You know what honey is? Honey is just bee vomit. And it vomits it back up again and mixes it with the pollen and passes it onto the leg, and the eyelashes go around, and so they can carry it in a satchel on the outside. But not all the bees carry it that way. This is another way. This bee has a whole bunch of spines, and the pollen gets stuffed into those spines, but it doesn't get mixed with bee vomit. So when you get home, you can shake the spines and clean them out, and you get the stuff out easier. But it makes you a really good pollinator, because wherever you go, all the pollen's in play. And if you go to the next flower, you drop pollen all over the place. So it makes these native bees way more efficient than honeybees or some bumblebees as pollinators, because they're sloppy. So here's a male of a bumblebee, and you notice that it isn't nearly as broad. It's convex, and it doesn't have those eyelashes. This has got straight hairs, and it doesn't have barbs on the hairs, so it can't carry pollen. And if you're really sharp and you're watching bumblebees and you look at their hind legs, you can see which ones are male and which ones are female, and you can catch a male in your hand and they'll go bzzz, but they can't hurt you because males can't sting. Now, a whole group of bees called Eniac Eyelids has got a rug on their tummy. And that rug is where they carry home the pollen, and their wings are arranged in a way so that when they have that completely full of pollen, they still have their weight and balance correct. If you see a longhorn bee with a white face, looking like they're having a good time and zipping from flower to flower and then off to somewhere else, that's always a male. Because the males don't have to carry home anything. They just get lunch, free lunch, and then they go looking for the girls. There are what we call sexual dimorphism in some bees. Not all, some. So this is a male of Coleoxys, and you notice that it's got 4 spines here. Look at the next bee, and this is a female of the same species, and it doesn't have those 4 spines, but everything else looks the same. So if you know what to look for, there is some sexual dimorphism in some bees. Here's a Ucerophrata, happens to be a female. So how many antennal segments? 12 antennal segments. Okay. So if we take a look at one of the tip of the antennal segment, this is an electron micrograph, and what you see on the tip of the segment is a whole bunch of sensory receptors. Each one is exquisitely sensitive to a whole variety of chemicals, and that means that this bee can visit a flower, and you see her here visiting the flower. She's got her antennae down on the landing petal, and she can smell the footprint of the bee that was there just a while ago, because just like we leave fingerprints everywhere we go, the police look for fingerprints. Bees have got stuff on their paws, their feet, and they leave a volatile substance behind, and she can tell that, and she also can smell the volatiles coming off the pollen. And so she's using those antennas to tell whether it's worth stopping or not. Okay, this is a Ucerophrata male. How many antennal segments? 13 segments, okay. So I'd ask you, why the extra antennal segment? Well, it's so the boys can find the girls. And this is about as romantic as it gets in the romance of bee life. There's a female in the center, and there's a bunch of males intent on passing their genes on to the next generation.